Hello everyone, it's December the 2nd. Alright, let's do this. Yep, that's exactly the same as what we had yesterday. The number of unique trapezoids that are formed by choosing any four. And it has to be convex. Yeah, I mean, it's basically, I just need to find different different slope, right? So basically you have these points, right? You have 1, 2, 3, 4, and 5. And for any two, you can have, this is the, so we want to know how many are on this, right? So in this case, there's nobody's on this. And so for this, I have this, this, and this. Right, how many do we have in total? 500. 500. So O(n) squared, we can get all of these. Right, we'll get all of these, and then we produce a slope. Okay, we can define the slope as, we need to define the slope. So we need to do some GCD stuff, right? Some GCD stuff, and then we have positive, we have negative, but it's fine. It's fine. So we do some GCD stuff, and then can we use pair as a key? Can I use pair as a key to map? Yes, you can. Okay, so I will use pair. So then we have basically each pair, right? For this, we just need to count, right? We need to count how many are in this. So for, like, say this is a map, and this is, you know, a pair, which is, you know, dx dy, right? So this is gonna give you a count. Right, for this, how many is in this, which is just total number. Total number. Oh, so basically we need to find crossing this. Right, we can have all the slopes. Yeah, we have this slope, and well, it's okay because we're doing this. So if I do this, so it's gonna be a set, and I'm gonna put number of points. Yeah, no, it doesn't have to be set. I just need to know the number of points that's on this. How do you know? Well, if I go this, let's say we have another one here, right? So I do this. What do you put in here? I put these 2 points in here, right? And I do this, I put these 2 points in here. And I do this, I put this, we just put the points in there. So now we all have the number of points that's on this, like, one thing, right? Like, how do you define, because I might have another one here, and they also have different points. So how do you differentiate this from this? That's a good point. That is a good point. Well, we can do, actually, because these are indices, I can just do index, right? We just need to say like these index belong together. These index belong together. So we can do union find. Yeah, union find, like when we get these, they got unioned. So when they got unioned, we need a parent. The parent can be this. This can be the parent. The slope can be the parent. Okay, so we don't use a map, we use a, slope. Now parent will be like, this will be the parent. Right, this will be, so this will be the parent. So these will be union together, and we basically do a find, right, on this. So we put this inside. So what I want is for the parent to be this. Okay, that's fine. That's totally fine. So we go small to big then. We go small to big, then we guarantee that when we do the union, we always union to the smallest one, right? So we have this map, so we get to the basically the parent. We'll put the parent index here. So we have another parent, we have another parent, and we have another one, we do the same thing, right? And then these parents corresponding to different dots, right? And then we just need to know how many dots are there. How do we find how many dots are there? Well, we'll know how many dots are in by taking a look. Do a count, right? Do a count. So every time we just say find this, and then we'll increment this parent, or increment the parent, so we know this parent corresponding to how many stuff. This corresponded to how many stuff. So each one we know how many, right? And then we will have this plus, if I remember correctly, this multiplied by this, right? That's the different combination you have, and you have the next one. So it's going to be this multiplied by this time this plus this, right? Total number of here, total number of here. So basically for this, I want to know how many in total. So I got this value. Okay. So I need to build a union find, essentially. We need to build a couple of things. So I need to build a union find. DSU, basically that's how we do it. So we'll do okay. I'll have a private vector parent. What else? We need a parent and we need rank. So this will be given an n, and then we say for 0 is smaller than n plus. I'm pretty sure. I think I can do this. And then we have Boolean union these two. I have find. Actually, I'm not sure. I don't know how to initialize these things. I think I'll just do this. I0, I smaller than n, I plus plus. Alright, we just need to... Oh, can I do this dot resize? I cannot see the private values? Unidentified. I forgot. To initialize an array in a class where the vector is a private member. I forgot. No, it is right. I just need to do it 2 times. I was right. We do this. Parent n0. Rank n0. Does not name a non-standard member or base class. So I don't know, maybe private has to go first? I have no idea. Parent does have to go, private does have to go first. Oh, it's because we define everybody here instead of in the header file. Okay. That makes sense. This is a boolean. I'll have find. So find x if x is not equal to find parent x equal to find x, return parent x. No, I think it's just straight ahead. Like if it's not equal to parent x, because if x is equal to parent x, then there's nothing we need to do. But if x is not equal to parent x, then we basically compress it. I think they have to be parent x. Parent x equal to, so it's x equal to find parent x. So this is find, right? So we should have px find x, py find y. Okay. And we say do you use rank to do this? Actually, it doesn't really matter as long as they converge to 1. I'm happy. If px is equal to, it's not equal to py, Actually, I don't even need to, we'll just say if it's not equal to py, right? So now we need to union them, right? So if it's equal to py, then we just return. There's nothing to do. They're already unioned, right? If it's not, then we say if rank px is larger than rank py, then we say parent px, parent py is equal to px, right? Because px ranks higher, so py's parent need to be px. Else, if rank py is larger than rank px, then parent px need to equal to py. Else, their rank is the same, then we say parent py will equal to px, and then rank px plus plus. Huh? What does this mean? Oh, declaration of anonymous union. Oh, huh? I cannot even do regular union. Okay, so this is a union find. So what else do we need here? We need a GCD. Right, so we make sure they're all positive, and then if A is big, and then A mod B. If A is small, B is big. Yeah, then we replace, right? And then we say if B is equal to 1, B is equal to 1. Should be 0, right? Yep. Return A. So that's GCD. So here is gonna be find all the slope and represent them with a pair. Find for each slope the number, the points that belong to the same line, right? We will use union find for this. Then for each slope, produce an array, of the array of parallel lines, right? And the number of line segments on the line. Then we can compute the number of trapezoid for each set of parallel lines. Okay, do we have a mod here? I don't think we have a mod, which is good. Okay, so we need to do a unordered map of a pair int. This is gonna be a vector of int. Right, this is a slope and line segments. So basically, what we're gonna do is we will go through them, and then we'll union find, and then we will we also need to have we need to have multiple things. Actually, this is not like it's a slope and slope lines. Okay, so the line, the vector is filled by the parent node in union find, right? Parent node in union find, which represents a distinct line. So we say for int I, this is, yeah, int I 0 I smaller than points dot size I plus plus, for int j equal to I plus 1, j smaller than points size j plus plus. Okay, and int g equal to gcd. Actually no, we need to first compute the slope. So s1 slope 1. No. It's just the slope. Now slope x, right, shall be points j 0 minus points I 0. Slope y is points j 1 minus points I 1. Right, and then GCD is SX, SY, doesn't matter, right? We'll get that, and I need to make sure that the negative always go with X. Okay. So pair slope equal to sx times sy smaller than 0. If it is, then if it's smaller than 0, then we always go negative on the s. So we go negative ABS x divided by g ABS y divided by g. Otherwise, ABS divided by g y divided by g. You don't have x, you only have x. Okay. Huh? This is a tertiary expression. I cannot use it? What the hell? Okay. Maybe we can do this. Sx equal to no, sx times sy smaller than 0. And if it is, then we say negative std abs sx. Otherwise, std abs x. This is allowed. No, this is just straightforward. Why? And slope is as simple as sx g sy g. Okay, so now I have a slope, we have the pair. Next, what we just need to do is we do slope lines if slope lines dot contains slope, right? If it now contains slope, then slope lines slope. That is slope lines dot at slope dot pushback. I need a union find, so DSU well, it's gonna be a points dot size. And then put indices in them, right? And push that DSU dot union I and j. Ooh, union. My bad. So union, if this will px, huh? Oh, I need to return the parent. So okay, if this is return this, then this is going to return px as well. This is going to return py. Oh, this is going to look ugly. So yeah. So this p, we define p parent as px. So if this, it should be p. If this should be py, If this is still p, so we can just return p. Okay, so now we union them. Okay, yeah, we do that. And then the next one we do that, next one we do that, so we get all of them in. So the next thing we need to do is find out how many there are. So we probably can just go through every single one and then we do a counter. So std vector int counter of points size. Okay, so for int I 0 I smaller than points size I plus plus. Now we say counter dsu dot find I plus plus. Okay, so now we have all the counter. So how many points are on each line segment. Then what we can do is we'll go through every single slope, right? So each one we know the count, and the next one, let's say 4 const auto p of key value pair of, I can probably do this and lines of slope lines. Okay, and then we can say int res equals 0. So we need to know the total number. So int current sum equal to 0. Current count, right? Current count equal to 0. And then for int L of lines, okay, so int num of points shall be L multiplied by L minus 1, right, divided by 2. Yeah, it's like 3 choose 2 is 3 times 2 divided by 1 times 2, right? So this is the number of points, and all we do is we have to have the current count and then cumulative line segs count. Okay, so we have that, and so the current count, so if num points is larger than 1, right, then current count shall plus equal to num points times cumulative line segment count, and the cumulative plus equal to num points, right? Not num points, num segments. Okay, so this is L. So num points shall equal to counter L, right? And this is num segments shall equal to num points times num points this, right? This is num segments, and this can be num segments multiplied by cumulative line segment count, and this will be num segments if it's larger than 1, right? So the first one is going to be 0 because the cumulative is 0, and now we have cumulative, and then the next one we can multiply it by that, and now we update. But if it's 1, we don't do it. So this will give me the int current count, right? And then we say res or plus equal to current count. And now we keep going, and at the end we will return res. Okay, let's see if it works. What? I don't understand. Is it hash issue? What does this mean? What does this error mean? Huh. But you just said I can use a map. Okay, so I cannot use it for unordered map, but I can use it for map. I'll take the penalty of extra. Okay, I have, but it looks very wrong. That's all right. This is why we are doing this. So we go map. Oh Lord. So this is going to be points, right? Points. Okay, this is a count trapezoid points. I'm gonna put it here. Hold a second, I actually have a very important thing to do. I forgot to pay my rent. Yeah, it looks all right. Yep, looks about right. That's the rent. And shit. Okay, I think we're good. Rent is paid. All right, let's get back to this. Wait, what? Check if, did I not save? Oh, hold a second. This is 3, it's not 2. My bad. Okay. Oh, let's debug this. Yeah, I think we're pretty close. I mean, the idea is very sound. Unless I got union find wrong. That would be very unfortunate. So we have these. Okay, so let's just see. We'll go F2. Okay, so we have DSU, parent. Oh Lord, parent is not correct. Everybody is pointing to 0. Did I not do DSU right? Dude, he used to be able to DSU very fluently. I don't know what happened. Oh shoot, I remember what happened. Gosh. Okay, so I probably cannot do it this way. I can probably do this way. Alright, this is a rank, and then say for int I equal to 0, I smaller than n, I plus plus, parent dot pushback I. Can I do that? Yes, I think I can. Alright, let's try that one more time. Okay, I don't understand. Still not right. What in the world? The union is not right. I forgot. How do I do union find again? Alright, let's see. Find if it's equal and equal to find parent equal to find parent v. Yeah, parent equal to find parent if they're not equal, and then we'll return parent. Yes, this is correct. And if they're the same, we already union them, right? If they're not the same, so oh, I see. The union has to be based on, oh, holy crap. The union has to be based on something else. So, like this, the ranking. Yeah, so the union has to be based on something else. It cannot be based on, because everybody will be union together. That's why it's wrong. The union has to be for the specific, right, for the specific will have its own. Then why do you use union find in the first place, right? Yeah, then why do you use union find in the first place? I don't think you need union find in this case, because all you need is this, and we use a set. We just want a set of points, right? We can do an unordered set of int slope. For this slope, what are the lines on? What are the points? Slope points, right? So we don't use union find, and then we say blah blah blah, and then we just not slope lines, slope points, and then slope points dot add this dot add I, right, and the slope points dot add slope dot add j, right? So like on this slope, those two are together. Oh, but that's also not right, because they need to be together. So for each one, we need a DSU. Yeah. For this slope, wait, hold. For a specific slope, we need a DSU. Right? For each slope, we need a DSU. For each slope, hold a second. We will use union find, and all the slopes that represent them, and represent the slope with a pair. Find for each slope what are the lines, right? And for each line, we use union find to gather all the points on the line, right? And then for each slope, produce an array of parallel lines and a number of lines. Yeah, I think this should be, so this has to be a DSU. For each slope, we need to have a DSU. DSU, right? So for each one, this will equal to DSU points dot size. All right, I have points dot size many times. Let's just do this. Points dot size. This need to be n. Points dot size need to be n. And here, n. Okay. So this and then b union ij. Right. So for this, we're union, and the other one will be different. Okay, yeah, this makes more sense. And then what? And then for each of this, we'll have basically different lines, right? So for each one of them, we need to count. So this will come here. Right, will come here. This is a counter. Right, so for I will find, actually this is not lines, it's also not points, slope points are going to be slope lines. Yes. So lines is a DSU, right? Lines is a DSU. So this is going to be counter lines stuff find, right? So we'll get plus 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 plus, so we have different, how many points are on each line, right? So we get the number of points on each line, right? The number of points on each parallel line. And then why this is done, this argument, wait, what? Function is not marked as const. I don't understand what it means. I cannot do line stuff find I. No, okay, then just we don't do const then. Okay, so counter basically say this is plus plus, okay. And then this is for the slope. And we have all the counts, right? Then we just need to go through the counter. So int count of counter, right? We go through the counter. Num points is the counter, right? And then this is going to be C. This is C. If it's larger than 1, we'll do num segments multiplied by cumulative num segments, and then we'll do this. Okay, let's try this one. Huh? What the hell? Something is wrong. Yeah, this is wrong. Okay. Now let's try it again. Candidate constructor not viable. I don't understand. I think I probably need to have a default constructor, which basically is don't do anything. Maybe that's what we need. Yes. Okay, it's still not right, but we DSU that this is the default constructor. Okay, let's build. At least. Oh, we don't have the. Oh. Okay, at least let's see the slopes. So we have 8. Is it 8? I actually no idea. 1, 2, 3. 1, 2, 3. And 4, 5, 6. 7. 8. Yes, it's 8. So the first one -3 and 1. -3 and 1. -3 and 1. It's no, x is -3. Y is 1. It's this one. Which one is this one? Oh, it's this one. -3 and 1. Right? -3 and 1. This one shall only have parent. Yeah, 0 and 1. Yes, that's correct. Right, that's correct. And the second one, -1 and 1. Which is this. Okay, this one should have more. Right? This one should have more. We have 0, 0, and 2. So 0 and 4. Right, 0 and 4. 0, 1, 2, 3. No, 0 and 4. Yes, 0 and 4. And 2 and 3. 0, 1, 2. 2 and 3. Yes, 0, 4, 2 and 3. And okay, this looks like it's good, right? So we go F2. So now I have a counter. So lines. Okay. So lines. Where is lines? Okay, so counter. Let's just see counter. 0, 2 times. Yes, 0 is 2 times. And then, so if we go through the counter, num segment is okay, so num segment is 1, yes. Oh, my bad. I think we should always, so we have 1 segment. No, 1 segment is good. It's 1 point is bad. 1 segment is good. One segment is good. There we go. Oh, if it times out or anything, then we will just... Oh! We passed the majority of them. Alright, so this requires some more debugging. Actually, it's not that big a thing. We just need to figure out what went wrong. Counter. What we can do is maybe if c is larger than, if c is small or equal to 1, I will just continue, right? And then we don't have check this. I can keep this. I don't know. This is good because one we don't care. And then let's see, use this. Not sure if that is the issue, but we definitely can try it. Yeah, still bad. All right, we just check the answer and then we go copy. Oh, do we need a mod? I don't think so, but anyway, so this is the copy and paste. Yeah, let's submit it first, and then we'll deal with it tomorrow. Reset. Yeah, so a little bit issue. We will try to figure out what went wrong. Anyway, that'll be it for today. I'll see you guys tomorrow.